You didn't give it to the sub? Were you here yesterday? But you didn't do the work? Dang. Okay, so we're looking at a square root. Number one's called a square root. Number two will be called a cube root. Number three is a fourth root, and four is a fourth root. Okay, so looking at nth roots, that's what we covered Friday. We call it n because it could be any of these. We could do any root, and that's what we're working on. Understanding how roots group things together. So number one should be no surprise. The square root of 121 is 11, and the square root of h to the fourth. So square roots all have invisible little 2's in here. So for every group of 2, you can square root and bring one out. So that means I could bring an h out and another h out, and there's nothing left under the radical. So there's no radicand left over. So the result is 11h squared. Good. March 4th. The end of third quarter is March 10th. It will have one more 100 site test. All right, so number three is a cube root, so I have to think of things raised to the third power. So maybe I have a list that I'm referring to. 2 to the third power is 8. 3 to the third power is 27. 4 to the third power is 64. You really want to be comfortable with these first three perfect cubes. So the cube root of negative 64 is negative 4. And that's because negative 4 to the third power is negative 64. The cube root of a to the third is a. And the cube root of y to the ninth. Well, if I split y to the ninth up into groups of 3, or maybe you still just want to write, 9 y's out. That's fine. But you should be thinking about them in groups of 3 because the index is 3. Every group of 3 can cube root. So I have a y that comes out, a second y that comes out, and a third y that comes out. Negative 4 a y to the third. Any questions on number 2? Number 3, you can split that fraction up. It could be written like this. So when you're taking a root, you can think about the numerator and the denominator separate. And the b that is like perfectly in the middle of the fraction bar, that should be a part of the numerator. So the fourth root of 1 is 1. 1 to the fourth power is 1. And if I was to break 8 b's into groups of 4, I would have 2. So the fourth root of b to the 8th is b squared. And the fourth root of 216, I'll have to test. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is 2. B squared over 2. Who's got a question about that one? Yeah. Yeah. Mhm. The B8 goes to the top. If it's right in the middle, it's a part of the top. It's not a part of the bottom. Oh no, you could do it. You could keep it perfectly in the middle like this. 1/2 B squared. That's good. This is even a little more official. All right, so number 4, 48 is not a power of 4. You put it in your calculator, you get a decimal. So you got to think about simplest radical form. So we already know 2 to the 4th is 16. 3 to the 4th is 81. So we're going to try to rewrite 48 using 16 since it's a power of 4. $48 is 16 times 3. Nothing. No, I'm going to go ahead and 4th root 16. The 4th root of 16 is 2. The negative just stays out front. And this is called simplest radical form. Okay, so 1 through 3 were all perfect roots. I didn't have any left over. But this one does. We'll start. So we have 2 things to check. We're checking the textbook work from yesterday and the workbook from Friday. We'll start with the textbook work from Friday, and on there, you guys go ahead and write this note down in your book, number 5. You're going to see some of the textbook answers have absolute value bars. And this isn't something I normally test on. It's a picky detail, but I do want to explain it. So when you're taking an even root of an even power, and there's one really good example in your textbook work you did yesterday. If the result is an odd power, you must use absolute value. I think this is the example. Yeah. So the rod is even, and then what you're putting into is either you must have an absolute value. Only if it's an odd exponent. That is so stupid. Well, it's a very intricate detail, and that's why it's not something I test on. It's very particular. Because x to the 3rd could come out positive or negative. Like if x was negative 2, it would be negative. X was positive 2, it would be positive. So odd roots can be positive or negative. So it's only in this very specific scenario where you need absolute value bars. And I think there's like 4 answers. So I want to explain that before you saw the answers.
Hey, Miss. Wasn't this homework?
Yeah, I'm checking it right now. I'm going to put the answers up. I'm going to take questions. I did it in class and I wasn't here. Yep. You better connect to the internet. I didn't do it. The textbook work from yesterday. Why do you guys think it's so Yeah, I think maybe the internet's gone.
Because the internet is there, but there's no.
Go to settings. And look at the Wi-Fi connection.
Oh.
Alright, so take a minute. Everybody who took the time to do this yourself and we're really thoughtful about this. Take a moment and think about where those absolute value bars are and see if it checks out with the note and if you can make a connection there. Now again, I won't be testing you on your use of those absolute value bars, but I do think that you can make a connection if you came up with the answers yourself.
See, I
Haley,
didn't
what's your question? So the absolute value bar is when you have an even root with an even power, and the result is an odd power. Very specifically something like this.
Yes.
Even root, even power, odd result. Three circumstances that have to happen.
Wait, miss.
Oh, one is an odd number. Who said that? Yeah, one's an odd number. Very good. Very good.
You want it like that?
Which symbol?
She taught me how to do this because I was and then I got the hand of it.
You need to start working with symbols you have that are different here. Oh, bless you. I wrote down
So when you're supposed to know when to use the exponent and then minus parentheses, and when you have to.
Give me your report.
It says it on 20. Well, you don't distribute on a lot of them.
Oh, miss, you can help me
I
with
remember
number
one of
25?
the questions we did, he distributed it, and I was confused on when he was.
None of these are distributed.
Yeah, none of them are. But I don't think
No, I'm looking at it. I don't see them distributed. So when we look at the workbook, if it comes up.
I just remember we did a problem in class and we distributed it, and now it's just like.
I would love to see this every fall.
Miss.
For sure. Does anybody have a question about any more 12 through 35? Should I work in you? You did. I got it back on. What did you do? It's only when this is even and this is even and the result is odd. But I won't be posting you on these absolute value bars. The negative has to be there because the negative is out front. It has to do with the even root and even power. Not the negative at all. It's not connected to the negative. Like here's a negative, number 16 is a negative with no bars. You said what? Distribution, but it's quite different than when there's a plus sign, right? I would never distribute into an expression with a plus sign. Alright, so keep this out. I am now going to put up the answers from workbook on Friday, page 83. And I am going to walk around and give you credit for both assignments right now. So both need to be out if you did both of them. No, 2 different grades. I'm grading them both right now.
Wait, miss, so you're not giving us credit if you didn't?
I am. It's 4 points for yesterday and 4 points for Friday. For 8 points total. No.
Was writing fun just like this? Or is it completely different?
I think it's actually a little bit easier.
Because that's from this year.
Again, think about those absolute value letters. Don't forget about them. I gotta pee really bad. Yeah. So you have the textbook where I'm gonna hit. See how 20 is the bars? Bones, do you have
When do we have the assignments done? Because I was in here Thursday or Friday.
as much time as you need? I just don't ever remind you which thing to come. Because it's zeros until you show me.
Okay. Because I can never come in after school. I have work straight after.
Yeah, that's why I started posting videos today. Oh, how nice.
And I have a question. This is really yesterday. If I should learn, then I was like, oh wait, I can get this answer. Are you gonna like talk?
No, I mean, a lot of those kids want some math. These, not today's work. You could so you could just do 4 divided by 2 is negative 3c squared. And then that's negative 3 squared is 9, and then c squared. Because of the parentheses. And so this is just like Well, how many groups of 2 are there? There's 1. So I think to answer your question, the correct talked about distribution there.
Please do.
No.
I did. Okay, then you should never mind. Anybody have any questions?
No, we can't. What did you say?
Alright, I'm gonna take some notes. I think we only have 3 problems, but it's kind of complicated stuff. Maybe more. Honestly, I hope there's more. Three to five problems. 6-5. So this heading here would work for your notes. 6-5 operations with radical expression.
They were good. They were good. I think so, bro. I know.
Alright, so we touched on this concept in first semester when we talked about never leaving radicals in denominators. And so today we're going to talk about how to clear radicals from denominators, like the whole process of it. So for example, the square root of 27 over 3, 27 divided by 3 is 9, that's square roots. Now here, it starts as one big radical, and the problem separates the top from the bottom. The cube root of x to the 6th is x squared, the cube root of 8 is 2, and you can see it could be written this way or this way, exactly like our bell root. Let's try a more difficult one. You don't need to copy this box down. You can copy an example. You don't need to copy the whole box. And that is in your textbook as well. What do you want to write? What do you want to write? What do you want to write? Oh, what you want, yeah. Oh, wait. Sometimes those examples can be really helpful, so I don't mind waiting. All right. Down numbers and radicals and exponents. Let's start this one by simplifying the top and bottom separately.
What's that like? Square after that.
It's a period. Ignore it.
So we have to simplify the top by what, 2?
Yeah? So what would the answer be?
4.
Yep.
So why 4?
Why 4?
What do you keep simplify from?
Right.
7? X plus 2 7?
Yeah, so unfortunately, 7's not an even number. So if I thought about 7, right, there's 7 x's. I can take out 1, 2, 3, and I would have x to the third square root x. Everybody okay with that?
Wait, hold on. Why you took out? How much you took out? 6? You took out 6?
I took 3 out.
Because you had to go by 2. I'll ask you.
You have to go by 2s. Though the rule is that we can't leave radicals in denominators. So we have to rationalize the denominator. And that takes something different every time. It takes critical thinking. You have to think about what would make this radical cancel out. So for this, if I had x squared under the radical, then I could cancel out one more x. So I'm going to multiply the top and bottom by the square root of x. So with fractions, as long as you do it to the top and bottom, you're still following the rules of fractions. And what we've created here is a radical that will cancel.
Yeah, wait, why did the extra Oh, because you saw it inside of that. I thought you were just not.
Cool, right, Max? Nice little puzzle. It's just a rule, like, so roots, square roots, cube roots that aren't simplified are said to be irrational. And mathematicians and scientists, they don't like irrational numbers in their formulas. So they simplify them. They do this, and then now that's something that they'll work with. I don't like to work with it in that middle step. Yeah.
Is this the same thing, like, so if it was like, let's say 4/8 and then over 3/7, would it be the same thing as we're doing it right now?
Yeah.
Yeah.
Why do you need more than 1 x?
Why do you need more than 1?
No, like, what if it wasn't square root but a cube root?
Then I would, and I only had 1. Well, then I need 2 more because I need to create 3.
So how would you break 1 out?
You multiply 2 in. I'd multiply the cube root of x squared to make a group of 3. I think my next example does it. Yeah, right here. This one's way more complicated. Way more.
Wait, so our final answer on the last one was why did
Yep. Man, can you cube root 9? No, what can you cube root? 8? Whoa, did someone say 27? Man, we really need a perfect cube. So since 9 doesn't cube root, we have to think about all the things that would cube root. 8, I like how you said 8. And someone said 27, and that's actually the number we're going to use. I said that just for So we're going to make, how would we turn 9 into 27?
Times by 3.
We're going to have to multiply it by 3. Why'd I do x squared this time? Jacob, why'd I do x squared this time instead of just x? Who knows? Why'd I do x squared, Joanna?
Because 3 squared is 9.
Nope. Nope, good try though.
You have to multiply it by a squared so then you can be able to cancel out
Yeah.
x.
We need x to the third. If we got a cube root, we need 3 x's under there. We only have 1, so you have to think critically, what would make 3? Well, 2 more would make 3. So what I got now is the cube root of 6x squared all over the cube root of 27x to the third. The cube root of 6x squared doesn't work. Matthew, what's the cube root of 27x to the third? Final answer. All so that we have a rational denominator, so we don't have a denominator in our radical in the denominator. Max, what are you doing? Put your phone away. Who cares? All right, let's try again. You guys ready to try again? I think I got 2 more.
Wait.
Wait.
Thank you.
Oh, no.
Thank you.
This is number 3. We're gonna do 4. So this is number 3. We're gonna do 4. All right, Max. What's the top gonna be?
Why are we putting a 3 there?
Oh, I don't know. Beep. You should take your thing out. Take it out anyway. If you don't know the answer to the top, you need to take that earbud out for sure. You must not be hearing me. What's the top? Well, I got 3 under there. And every 2, I can take 1 out. How many is that? That's 8.
So it's so your left is x over y.
The x is non-relevant anymore. The x is in the top. We don't care about tops. This whole scale is working in bottoms. How do we get rid of the square root of y? Yeah, you can. You can multiply anything. Shouldn't say that again.
Where did you get y squared on the bottom? Oh, my bad. I didn't. I thought you did the purple out.
When we have an individual variable and there's square root that's the ratio x, don't you just have x there? Because it's just one.
The result? Yeah. All right, I'm going to skip the last question and jump into homework. What number? First one.
Oh, I don't think I'm gonna come to school tomorrow.
The straight hairs in the back of your head. Really giving me life right now.
I remember this morning.
Yeah. Don't even say it. The straight hair is giving me a life right now. Go ahead. I have an inflamed scalp. But I don't know why. It's like red for no reason.
Max, how do I get rid of this 7 down here?
What?
How do I get rid of that 7? 7 doesn't square root. What number would?
You multiply it by 10.
Yeah.
Squaring 7 on both top and bottom.
What's the square root of 7 times the square root of 7?
Square root of 49.
Ooh, that's a good thing. What's the square root of 49?
Good job, right?
The process of doing this just helps you understand power of thought. Yeah. Before? After? Yeah. What Which one are you getting that for?
Number 12 on page 86.
Okay. So you got circle.
Hold of that. Hold of that.
Oh, you were here say before.
Here the 8. Primate. You literally missed.
Which one should I do next? Number 10?
I'm working on it real quick. Don't give me the answer yet.
Roll it right back at you.
Matthew, what are you going to multiply 10 by? I don't care about the time, I'm only worried about the time.
You can only 10 by.
Oh, God. Why was that so aggressive?
Really radical. What's satisfying?
Bro.
You were so high now.
That's my new paid face, actually. What even is that? No, no. Like, no, but like,